finishing it. So yeah, that's the way, because I really apologize, because I had to pack the content in that manner. Otherwise, the other things that I'm planning for session 2, 3, 4, and subsequently requires this kind of understanding, because if I start to do some statistical deep down thing in the beginning, in the second, then probably I will lose the audience. So yeah, I recommend review this and the basic things that I am giving, and probably many people already know R, or they have some of similar like experience. So for them, it should not, it is kind of a basic, very, very basic. Okay, it seems R is not for me. Yeah, it's very difficult because R has a lot of things to offer. So who knows, probably you're saying, you are thinking it's not for you today, but tomorrow it may be.
স্যার আমার একটা কোশ্চেন ছিল স্যার।
ওকে
স্যার আমরা যে ভেক্টর দেখলাম স্যার, যে কি বিভিন্ন টাইপের ডাটাগুলোকে আমরা একটা ক্লাসে নিয়ে আসতেছি স্যার, এটা কি আমরা ফোর্স করে চেঞ্জ করতে পারি, যে নিউমেরিক থেকে আমরা সব ডাটা ইন্টিজারে নিয়ে আসলাম, বা ইন্টিজার থেকে সব ডাটা ফোর্স করে আমরা নিউমেরিকে নিয়ে আসলাম, এরকম কি করা?
উইদিন দ্য ভেক্টর এটা সম্ভব না। ভেক্টরে মানে ইনসার্ট করার আগে আমাদেরকে ওইটাকে ডেলিবারেটলি কনভার্ট করে নিতে হবে। সো ওই কনভার্সনের জন্য অ্যাজ command, I'm just writing here as integer. If I type something like this, you can see as integer. Okay, so if so আমাকে কোনো ভেক্টরে ভ্যালু অ্যাসাইন করার আগে I have to do the conversion by myself, because ভেক্টরে always একটা highest precedence convert হয়ে যাবে. So if I have a integer and a numeric, আমি যদি if I want to keep these things together, তাহলে ওইটা highest ভ্যালুতে কনভার্ট হয়ে যাবে. So integer will be converted to numeric. বাট আমি যদি একটা টাইপে রাখতে চাই, দেন আই হ্যাভ টু কনভার্ট ইট বিফোর টু দি যে রুট ফর্মে আমি রাখতে চাচ্ছি সেইভাবে, অ্যাজ ইন্টিজার, অ্যাজ নিউমেরিক। ওকে, দিস আর দ্য কমান্ড। অ্যাজ নিউমেরিক, ইফ আই সে 5, then it will be like this, 5 is 5.
স্যার আমরা কি পুরো একটা ম্যাট্রিক্সকে এভাবে চেঞ্জ করতে পারবো স্যার?
না, ম্যাট্রিক্সে কোনো সমস্যা নাই, ম্যাট্রিক্সে যে কোনো ভ্যালু যেভাবে থাকবে সেভাবে হবে। ইটস অনলি দ্য ভেক্টর। ম্যাট্রিক্স কুড হ্যাভ ইন্টিজার, নিউমেরিক, এনি ফর্মে থাকতে পারে। হ্যাঁ, শুধু ভেক্টরের ক্ষেত্রেই অ্যাটমিক টাইপ।
So another question, so I can see like when you write like as integer 5.66, it's become 5, but in generally in Excel or DAX, so it's becoming 6. Like what is the basic difference?
ওকে, বিকজ এটা ইন্টিজার পোর্শনটা নিচ্ছে, এটা ওইটা যদি আমি ফ্লোর বা সিল করি, ঠিক আছে, আই থিঙ্ক ফ্লোর যদি করি 5.66 or 5.55, it will be 5, but if I do the seal, I think sealing, then it will be 6. Okay, so these are the different mathematical operation. Excel এর ক্ষেত্রে always sealing বা flooring হতে পারে, বাট আমি যখন প্রোগ্রামিং কনটেক্সটে, হ্যাঁ, তখন এটা will take the whole integer, whole part, যেটা it will not convert to the nearest whole.
Okay. Yeah, different system have the different style or different coding system.
Because Excel is not programming. Excel is actually a program software. Here you are doing real programming. So eক্ষেত্রে 5.66 could be 5, could be 6, could be like different based on the different operation you can do.
Yeah.
So please use 5.33.
Oh, 5, anything should be like if a seal will be less than, then it will be always making it up. Okay. And if I say floor will always make it low. Yeah, anything like that. Then it is up to us if I want to do this command, like if it is above this, then it should make it 6. The conversion rounding, I think round is another one. Round, if I say 5.33, sorry, 5.33 will be 5. If I say 5.43 will be 4, 5 point above 5, it will be 6. Okay, so there are different operations. Yeah, we have floor, seal, round. These are different mathematical operations that transform the data as per rule.
I think Excel is using round.
Yeah, Excel probably using round. ওকে, আমরা তাহলে নেক্সট ইসে যাই, বিকজ আচ্ছা আমি তাহলে আগে একটা কুইক রিক্যাপ করে যাই, হোয়াট এভার উই হ্যাভ লার্নড, দ্যাট উইল বি বেনিফিশিয়াল আই থিঙ্ক। সো আমি এখান থেকে জাস্ট কুইকলি, ওকে, our syntax is like any other language. We have a specific syntax that is followed in R, and R is very easy because it doesn't require declaration of variable. You can straight away write the code like print. We don't need to include any standard library or anything like that. Automatically it understands the print is a command and you are writing something, and it can work as a computer, as a formula. You can write it and you can straight away get the expression. Then if you with the hashtag, if you write anything, the computer or the program doesn't look it. It is actually a comment for the author who is writing the code, so that you can understand what kind of logic, what is explained. The key thing is the variables. For any programming language, variable is the essential thing. It is nothing but a memory space. Okay, you declare a name that essentially allocates a space into the RAM, and we are accessing the RAM space using the name. For example, my age, if we declare my age with the value 35, then in the RAM, there is a specific location. It gets a storage address, and we are accessing the address like a postal address, like by my age. Then computer memory can deliver that data from that specific location of the RAM. Okay, and this is how we variable are important. Variable is just a placeholder where we can store different data types. In R, there are basically 5 primary data types, or the atomic data types: numeric, integer, complex, character, and logical. Logical we also call Boolean. It can either have true or false. It's all capital true, all capital false. If you mix true T a small k, then it is not a valid expression. It has to be all caps. Or you can also do a simple T or simple F with caps. Okay. Then we can do different operations on the variables we have. For example, if we have the variables x, y, and we can do arithmetic operations, we can do comparison operation, which is ultimately giving us a true or false answer, which is helpful for build up our if-else expression. And logical operations is basically when we have two comparison operations and we want to combine those two comparison operations in a complex way, then we use the logical operations. For example, we have one true expression, we have another true expression, we want to say whether both of true or either of true. Okay, if we have multiple expression that is giving either true or false, then we are combining them using a logical operators. So there are two kind of logical operators, which is and or. Okay, so there are bitwise or like a element-wise and then element and the logical and. So we have seen some example with the logical and, where we have a logic one and double and logic. But when we'll be using the data frame and other stuff, we will using the element-wise. Then we are talking about multiple elements that should be treated in parallel to make a logical check. Okay, but in this case we have one expression, another expression, and we want to checking whether both of the expression are true or false. Then we are using this double and or double pipe. Okay, but we have not seen any example yet with simple and one pipe, but subsequently it is coming next. And then we have seen if a statement is the only way to make conditional statement in R. So we have to use if, then bracket, the condition, and then we have to start the curly brace and a begin and end. And if we have to continue with further exception, then we have to use else space if, and condition will flow. And ultimately the ground, like ultimately if you don't have any other condition, we end with else. So if, else if, else if, else if, else if, else. This is the way of doing else. And we can also have if nested if. So I have not spoken that. So if this example is showing you, we can have if statement, and within a if we can also have another if statement. As you can see, if x is greater than 10, then again we are checking above 10. So within the 10, if we say if x is also above 20, then we are checking that under this if. Okay, and then otherwise this. So this if begin, and this is the end of this if. Within this begin and end, there is another if statement came, and this is called nested if, and that is possible. So for example, you have a condition, and while meeting this condition, you found there should be another sub condition to be met. Then we use that kind of if else within a big if, or within a condition. So that kind of if within a if and else, and within that another if, another, even within this you can have n. This way you can get maximum of 255 level of nested if else. Okay, but we don't use that so many. Probably 4 or 5 levels of if else is enough. And yeah, and this is a kind of a logical operations. As you can see, the and, okay, this is actually bitwise, like a element wise. So x, y, and they are comparing this condition and this condition, and we are comparing this with or condition. Okay, that is a like a operation and condition and or condition. This is element wise and, but we can use the same when we'll be using the data frame as well. Looping are in 2 flavors in R, which is the while loop, another is R for loop. While loop requires a condition to check first, and before you check this condition, you have to set a initial value for this. Otherwise, you may run into some kind of a scary situation. If the value is not set, then probably it may not run, or if the value is over the bound, then you may not run this while loop. So make sure you have initial condition is correct, and then the value would, the loop will continue. And you have to be careful that the condition you are making here, to make it true, you have to take some action within this begin and end, so that it becomes false after some time. Otherwise, it will go infinite time and computer may crash, because if you don't have a stopping condition coming here, it will go on forever. And then you have to press all Control Del, or probably Control C, Control V, Control X, something like that, to break this thing. Okay, and yeah, and similar to a while loop, for loop also works the same way. Okay, we saw that. We'll see. And then R has a functions. We can create our own custom functions. So custom functions are nothing but a group of code where we give a name like this, name a function, and then we use a function as a keyword. And function actually has a receive parameter from external caller or external word. And then using those values, we do some calculation within this functional block. And finally, the result of the calculation, we can return it through return statement. So whoever is calling the function like this, in this case, that receives a value, which is the return value from the function. Okay, so it is like f of x, for example, this function of x, and this is the x value. And using the x value, you are doing some calculation and returning the result, whatever the value of the x is, and you are storing that result by into the variable which is calling this function. So this is how we call the function. In this case, the name of the function, I think it's a underscore, it's a mistaken. So a vector underscore multiply should be there. And then you are passing 2 parameters, the vector 1, vector 2. This is a vector 1, vector 2. And of those vectors have been multiplied, and I've used another function called prod. So it's like a dot product of the 2 vectors, and you can get the result. So this is how we actually function. And I didn't mention that, but now I'm since we have got some understanding of function, I'll take the liberty to explain it now. There are some nested function as well. Like we have seen the nested loop or nested, we have seen the nested if. We can have a nested loop. So loop within the loop is also possible. Okay, so you create a loop, and then within this loop, you can have another loop, and within that loop, you can have another loop. Okay, that's called nested loop. So that nested loop and nested statement and nested functions are also possible. Okay, so in this case, the function nesting could be having usually can have 2 flavors. One is the function within a function. Okay, so we call function with another function, not within a function. He's there. So we are calling function in another function. So in this case, look, this is name of the function is nested function calling, and this is the definition of the function, which is x and y are the parameter, and a, x, and y is added and return value. Now we are calling that function by this nested function, and the parameter of the function is actually the nested function, the function itself, okay, with these values x and y, x and y. What it actually does, it first, this calls happen, it goes 2 and 2, so you get 2 and 2 added, you get 4. Then second function calls 3 and 3, so 6. So 4 plus 6, then it becomes like a 4 and it becomes 6. Then it is still the same function, nested function. Then it calls again. That means first call, second call, and third call, you get the 6 plus 4 plus 6, you get 10. So finally, this function returns 10. So this is how we are getting a nested function. The other nested function is interesting. You create a function itself, and then within this function, we create another function. This is the begin, and this is the end of it. And within the begin and end, we create another function called inner function. You can give any name, basically. This is the, for simplicity, this is the function 1. This is the inner function, or function 2. So once we call the function, we always call the outer function. That eventually returns a function, inner function, okay? As you can see, return the inner function. Then we have to call this inner function by saving the output of the function in a variable, and then pass the value, which is the y, in this case, a 5. So 5, first it calls the outer function with the 3. It gives us the value with the 3, with the function set, and then we get 5 plus 3, then 8. We get 8 in this case, okay? So, but we rarely use this kind of structure, but this is just for your like a just understanding that this is also possible. If you see some code doing this, that means it is doing this, but we rarely use this kind of complex like a function behavior. We use this kind of thing. We use this frequently, but we rarely use it in our function. And another function is called recursive function, which is the, for example, from mathematical things, if you want to factorial of 5 equals to factorial of 4 into 5, and then factorial of 4, you can see recursively, if you want to calculate a factorial, you go on a functional call on after another. That's kind of recursive function is also possible, but I'm not going to take your mind away from the complexity of it. But this is another type of function called recursive function. If you're interested, you just Google, or you'll get some idea. Then I'll be talking about the different data types we have seen, but these are the complex data types using the atomic data types in a vector. The vector is a list that can contain only a homogeneous type of data, so it is the same type. List is a list itself. It contains a list, but that can hold different data types, okay? And we use append function to add the item to the list, and we can use the in operator that we have seen as miscellaneous operator to find whether any item is present within the list, okay? So that in operator we'll see in action. Metrics are like a two-dimensional array. You can see if the array like, but it has a number of row and column, and you can access each row, column, or any specific item in the row. The function to add a column, we use cbind. To add a row, we use rbind with a set of with the metrics and the value with a vector. Obviously, we need a matrix and a vector that should be added either as a column or as a row, and that should match the number of items. Now we'll be talking factors. Factors are essential because once we may have categorical data, right? These are, for example, from a demographic point of view, we have male, female, we have music, which could be rock music. These are the different categories in music genre. Then we could have the training, like a strength, stamina. These are all categorical, you know, right? So if we want to convert the categorical data to numerical, because as you can see, computer cannot process, no machine learning can process the numerical, the text data. We have to ultimately convert it to number, because number could be represented to zeros and ones. So while all our categorical data has to be represented through numbers, and that's the way R converts those to factors. So imagine this is an example. We have a list, like in this case, a vector. There's a music genres, and if we call the function like the method called factor, okay, that factor, it actually factorizes these things. What it does is look at the output. If I say factor of this vector, that means it gives us a different levels. So levels are like a classic jazz. So it gets the unique items from all those different things. You can see only there are 4 items. It's the length of these levels. You can see the levels, and levels got numerical representation. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. There are 4 items. So these factors help us to convert the categorical data to a numerical data through factor. And I'll show an example here so that you get more clear understanding. So factor in this case, I just take it here. For example, we have a division, a lot of data. Like, so if, for example, you are thinking about a survey and you got how many divisions. If you say length, in this case, if I run this one, so let me just clear it. So run it again, and then clear it. So length of division. You see, there are 33 survey response. For example, I just taken one of the column name called division. So there are 33 responses and across different divisions like Dhaka, Khulna, and Chittagong, things like that. Okay, and this is repeatedly there. Now I want to convert that division as which was my categorical data to some kind of numerical representation. How we do that? I do the factor, and this is my division is a variable. Okay, and I know the levels. I know there are 3 levels because the Dhaka, Khulna, and Chittagong, I got it there. And then these levels should be converted as a levels 1, 2, 3. So if I do that in the factor, and then if I print the factor variable now, which is a new factor variable, you can see my division is now converted to 1, 2, 3, 1, 1, 3. So 1 is for Dhaka, 2 is for Khulna, 3 is for Chittagong, and you see the 1, then 3. Third item is Chittagong. So 1, 2, 3, 4, 5th. 1, 2, 3, 4, 5th item is 3, is a Chittagong. So 3. Okay, so that's why you can see all 33 variables, 33 input has been converted to numeric. And once we have this numeric, so dummy variables, things like that, in statistics, that will be easier to handle. So this is factor.
It is possible to count the how many unique value.
Yeah, so that is the levels. That is the length of the length.
Can I input the manually if I want to count the number of unique value from the thousands
so
of
you can you can do the unique of divisions. So you can see these are the unique values. So there is a command called unique. Okay, so that unique gives us the unique number, or I think distinct. Now in this case, distinct is a different package, but unique give you the unique from this. So I paste the vector in this case division. It gives you the unique numbers, unique things. Okay. Okay, so this is factor. So you got the idea of factor. Now the next data type, which is very, very essential, and mostly we'll be working on that data types, which is the data frame. So what is a data frame? You can think about data frame is actually a regular Excel table. Okay, so since you have been talking about Excel, look at Excel. Excel has rows and columns, and every column has a name of it, and then column could be of different data. So a column could be of a vector type, one could be your gender, one could be your age, one could be date of birth, one could be your another numerical data, it could be another text data, things like that. So data frame is exactly like that. We can create a data frame by using data.frame. And you can give these, like a training is the first, as a one column, then pulse is another column, duration is another column. So that way we can create a data frame on the fly. And if you print the data frame, it will print like this. The training is the variable name, pulse is the vector, and the duration that becomes automatically column head. So this is the data frame. And let's take an example and we see the data frames in detail. So in this case, we created data frame, the example I just showed. Look, in this case, what I'm training, this is the one vector, right? Look, it's still, look, we are creating the variables which are already known to us. This is a vector, we can see that. This is a vector, we can see that. This is a vector, we can see that. And we are putting the different vectors into another, like a packet, like another complex data structure, which is a frame. Okay, same, we can do it as a list. Like now we are putting in a frame, and what does it do? So, and look, this is a numeric, this is an integer or numeric data. We know this. We know from this atomic to the like a more complex, and this is like another complex data. So this is now actually we try to understand. We can understand. Okay, this is a vector within a vector with a data set. So let's see. We run it, and now if we print this data frame, you can see this is the data frame we have. Okay, so it's a training has these values which I have given. Pulse has these values which I have given. Now, if we want to, I think now we try to add new rows. So I just add new rows to this data frame.
One additional thing. This function can be run in the Excel or any other platform, any other database platform.
No, Excel is different than this one. Excel, you cannot do, yeah, how will you integrate Excel? Like, I am not sure what you have asking.
I am asking you that I have a huge amount of data in
Yeah.
any database format. How
Oh,
can
yeah. Yes,
function?
yes, you can. Yeah, you can read data from Excel to here. Okay, so if you have an Excel file, you can open an Excel file and get that data on your on this interface, and we will see that tomorrow. Basically, okay, we will see some Excel files. Yeah.
Export the data again Excel. Can I export this after processing the data? Can I export the data from Excel? It's possible.
So you can read data from Excel. You can So I'm just quickly show you so that you become more familiar. So no. So now we have a data frame. Okay, yeah. So if you write, you see write.csv. Okay, this is a command which can write the data to a CSV file. So in this case, we have a data frame called now this data frame, right? Data underscore frame. And we want to save it as a test.csv, right? And it is already written. You can see this file. If I refresh it, it should be, I'm not sure it is written. So probably I have to make it as a directory here. Then if I run this command again, yeah, I can see this file is here. And if I open it, open view file. So I have to open my Excel file. And then if I go to my file and open it, open browse is on my desktop. And it is a KUR session 1. And I have to say all files test. You can see I got this file in Excel. Okay, so it's just simple. I have read that I created the data in the data frame here. Here I created data in the data frame. It was not an Excel file. I saved it as an Excel file, right? And same way, I can also read the file from Excel and load the data here. So we'll see some examples like that. Okay, so let's move. Now we are data frame and how we can add a new row to because we have seen our data frame is like this. Okay, we have seen our data frame has training and we want to add another row to our like a row to this data frame. So this way, and if we print this data frame again, you can see our strength it's got it like a new row. So row require 3 values. First row require a value called like a strength, their pulse, and what else? I think the pulse and duration. This is a pulse value and the duration value. Now, how we add a new column? For example, if you want to add a new column like a step, the column name is a step. If we see bind, so we are adding a new column called a step. And if we print the new data frame, you'll get a step. And these are the values for the step. Because since there are 3 datas, in this case, we get a 3. But if you give 5 data, what happens? If you try to add these things, it give you a complaint because you are giving more data than it is available for this rows because it doesn't have any matching row to incorporate the new data. So that means it has to match the number of data already there. Otherwise, you cannot add, you cannot bind it. Okay, that's why because there are 3 data already here. So it is good to, you can have another data on the data frame. Okay, otherwise it will give a complaint like this. You can see it doesn't match 3 by 4 row. Okay, so the way we can know the length of the data frame or the dimension is a 3 by 3. The dim function, the length of the data frame, how big the data frame is a 3 because of the row and column wise, and the number of rows we can see here. And the same way we can also do the distinct function. I think the unique function, unique of, if you want to say data frame, I think my variable name is data frame, and this is where we can access the individual column. Okay, since this data frame has 3 columns, so how we know that how many columns are there? If we say call names my then data frame, then it will give me the name of the columns of my data frame. It's like a table. Okay, so you have got a table. So if we print the, look at the data frame, this is actually a table. It's telling this is my column 1, column 2, column 3. This is my row 1, row 2, row 3. Now in the table, massive table, if you think that there is like hundreds of columns, in order to know the name of the columns, we just use the command called call names. Call names give us the column name. Okay. And then how many rows we have in this n row? N row give me, and then data frame give me the number of columns. Okay, this is the way. And then if you want to know the only the distinct values available into the training column, okay, imagine we have a lot of columns, just I want to only know the data available in the distinct and the training column. To access that, we use this format, like a data frame, this the $, and then automatically variable will pop up. Okay, then training will give up the list of the variable. These are there, like a strength, stamina, and other, and automatically this is are identified. This is a label data, it's a categorical data. Okay, and if you want to know the distinct of this one, unique. Okay, how many unique value of there? Imagine if you have thousands of records like that, just I want to know the unique of this. Say these are the unique values, although because in this case we have 3 and 3 are already unique in this case. So we'll see more of the data frame tomorrow, but just get to familiarity, the data frame is nothing, just a table which has this like a head and the heading, and then using the heading that becomes a variable itself to access it. Okay, and we can use the rbind and cbind to add those the row and columns. We can add multiple like a data frame together. So you have, for example, one data frame here, and we have another data frame here. Okay, we can join the data frame together. We can rbind, okay, as a new data frame. And if you print it, you can see these 2 data frame has joined together, okay, by row bind. This is row wise. So we have to take data frame 1, data frame 2, and they are the same data frame type. That's how we can join their row. So imagine if you have 2 split file, exactly the same rows, you can use rbind to make a big data source. And in this case, we have a data frame which is having 3 rows, and we have creating another data frame which is having only 2 rows, like a 2 columns, so 3 and 5 columns, and we want to add this 2 column as a 2 column, like as a 5 column data set. Okay, then this is column cbind. So if we do that, we will get ultimately a 5 column data set. You can see 1, 2, 3, 4, 5. So, and obviously everyone has 3 records. You can see the 3 records are there. One is the training, pulse, duration, steps, and calories. Okay, so this is how we are using the cbind to combine the rows and adding those combine the columns. C for column, R for rows. Okay, so that's it. So we basically understood the data frame, and we'll see how many operations we can do using data frame. I think a little bit of more tips on data frame. I have here, there are some available data frame already in R. For example, we don't look in the package, we don't do any kind of inclusion like any library or anything at all. by default includes all those libraries. So you can have a look what kind of libraries are automatically added here. So look, user library, these are not ticked. So if we go scroll down, when we load R, I think there are some default packages which is already been added. So it should be, there should be at least one tick somewhere. Like could be a stat package or something like that. But I cannot see anything yet. Let's see. I can see, look, this is one package has been added here. And then, yeah, some packages are by default added. Base package, you can see system library base package is already added. This is the base package, which is providing us that if we are writing print function, that is coming from base. Okay, so we are automatically, when we run this program, although we have not added any library or anything, how come this is knowing? Because base package is having those commands, and some data sets are already added. For example, in this case, I'm about to show you a great data set which is available here, which is the air quality data set. Where is that one? Here, look, data frame air quality. We are loading into a data frame as a this, and then print. If I say df, you can see this is the data frame already loaded. Okay, this is a data which is the ozone, solar hour, wind, temperature, month, and year. It's coming from some of the countries' data quality data. Okay, and that is coming by default from the data sets. Okay, and now same way, if you want to know only the temperature field of this data frame, we can write this variable sign that we have just known. There are 100 and how many samples? 153 samples are there. Okay. Yeah, so this is how we will load the data frame. Probably we'll read an Excel file and do some manipulation, do some statistical analysis. Okay, and interestingly, if you summary is if you say df, you get a summary of every field, every column. So summary of, because it's a numerical data, so summary of the minimum, first quartile, second quartile, if you know that kind of quartile range for quartile, the first quartile, median, mean, maximum, and there is null values. And is giving a summary of each and every numerical variable we have, okay, in this case. Okay, so if we say summary of our what variable, we have the data frame. We have created our own data frame. Which is this one. You get a training because this is actually non-numerical data. So we get the categorical representation, categorical summary statistics, and this is a numerical duration and pulse. We get the summary statistics already. Okay, without writing any single line of code. That is coming from base package. Okay. Okay, so I think this is the source code I have to take you through, but once again, from the beginning, I just have a quick recap so that you don't get lost. So, and I put necessary comments. Look, for the first part, variable and vectors. So I have declared the variables here, just clear everything. I'll just quickly run again so that you can also match my output when you do it by yourself. Vector variable, there are 5 variables of different atomic type variable, atomic type data. If you run it, you see the output here. Now vector contains the atomic type of data, and based on the type precedence, it converts to the highest level. That's why in the vector 5, we got all numeric, but you can see gradually the precedence are polluting or upgrading the values from the variables. And we can use len, sort, print function.
What does it mean by the C in second line?
C is for combine those variables. Okay, it's a kind of a C functions. So if you want to know what is C, I think let's see. Yeah, C is the combined values into a vector. Okay, C is basically, this is the way we give a list representation or combine these values.
You also put in the C there.
Yeah, but it's not required. It's not required. So it's just a 1. So it is also valid. Okay, so it is still then a numeric. Okay, so this, and then we created a list. How we create a list? We use the list function to create a list, and we can create list of different vectors. As you can see, I have created list of list. So this is actually a kind of a list, which is a vector, but vector list can contain heterogeneous data types. So these values are preserved within this. You can see it's not been upgraded or downgraded. Similarly, we can also list of some characters, and then we can access the items by their position. So I just write in this case, if you want to access the fruit, okay, I have to first run it. Then if I want to access the first item, a fruit list, I will use the index of that first item to get me the first item. You can say apple. But if you want to remove the second item, I use minus sign to remove it. So it will be removed, and new list will be preserving the new list, which is after the removal. I can see apple and cherry, banana is removed. Same way, I can add item by append function. And if I provide an index, that will append to the right location I am providing index for. This is for your extra who knows, who has already have some experience. This is for them to jog their mind. This is a kind of a recursive list within a list. So if you run it, you can see there are different kinds of output you get. So list, if you say recursive true, then A is appended with B. So A, B, A, C, you can say A, B, A, C, and then you say B, C. If it is non-recursive, then you get just B, A, B, C as a list, okay? This is for them, those who are a bit advanced or are more onto more warm up their memory or the brain, they can try this on. But we rarely use this kind of expression. But this is also possible. Then we talked about metrics. Metrics is nothing but a two-dimensional array-like things, which we mentioned the number of rows and columns, and the value you provide. It could be flow through either row-wise or column-wise by providing the row by row true or false. And as you can see, it's by row false. So you can expect the value in this case is going by column. So 1, 2, 3, 4, 5, 6. And since the value is finished out, but we have given 3, the start from the beginning again, 1, 2, 3. Okay. And we have seen how we can access the individual items as a first row item, row index, column index, and we can use the only row by providing row number, on the column, but be mindful of this comma, because that will give us the all items on the first like a row, like means all columns first row, and likewise the columns. We can use the cbind and rbind to combine the data to the column wise or row wise, but mindful that we have to have the same number of items. If our 3 items, then it should be 3. If we give 4, then say mismatch. So I cannot accommodate that. And the way we can remove it, it has to be minus the index, okay? The number, which position you want to remove, that's the negative number. And you can try different numbers.
Value, yes, C is essential or mandatory?
C is essential because the -1 doesn't mean anything, okay? The C is in this case giving a positional information, okay? So this is the position.
About the line, when you input the addition.
Okay, let's see. I've not tried it. Let's see if this thing happens. What happens? I think in this case it works because, but C, the good practice is C because always you may have multiple options. So if you like a combine C, we provide C for more than one. But if it is like 1, then probably C is not required. Okay. So in this case, it works perfectly. So in this case, the matrix, we have this and it removed the first item for first row, first column. Okay. So
I want to say about the cbind function. Here C.
Oh yeah. C is essential. Yeah, without C, you cannot do, because this is a value, like it's a together value. Okay, it's a combined value. It's a vector. Okay, it is a vector because look how we create a vector. We create C to vector, right? So you are passing a vector to this matrix. Okay, to so
we
vector.
Want to pass the value other than vector, then it is possible.
No, because matrix requires a vector because it's a dimensional thing, right? It's a dimensional thing.
Okay. Understood.
Yeah. An array I didn't mention, but this is for the advanced. If they want to look at how this is a multi-dimensional, it's like a 4 by 4 by 2 by 2 dimension. Okay, so that means it can be like a many, like each first dimension have this many dimension, then this has this many, and then this has the 2 by 2 matrix. So it is a very like a complex, and these are the columns. So you can access this. So those who wants to give it a go, but we rarely use that kind of data structure. We mostly we use the data frame, which we have seen. Okay, we'll not use array. We will use metrics and data frame mostly in many cases. Factors we have seen. I've told you the factor is the way we convert the category data to numerical form, as I mentioned here. Divisions we convert it to like a numerical representations. Okay. The last part is the data frame, which is the we can load a available data frame. We can have a look, and this is the way we create a data frame. We use the data.frame, and if you want to know what is a data frame, just help data.frame. Okay, you can read the help how it works here. These rows and things like that. It's a good help here. This is the way we can learn more about the functions that are available. But the essence is we use data.frame and then give the column, and the necessary vectors that should populate that column. Okay, so these are the values underlining the column, and this is how we create a table. It's a vector. The data frame is nothing but a table with the heads. Okay. And we have I just showed you briefly how we can convert that data frame to a CSV file. Just write.csv is the function that can spit out the data into a CSV file. Yeah. So so this is a vector, as you can see, and I have some other example. You're creating the data frame out of those vector, and you can use summary function to get the summary of the data. And interestingly, this is a data frame is car. So you can see the DF2, which is also available data frame in the this card data is already available in the data frame and in the R package already. Now we want to see look at the data column. It has the speed and distance. Now we can off the shelf use a like a operator. So I want a subset of the data from the data frame DF2 for which speed columns value is greater than 20, because you can see speed varies from many ways, but I want to only get a subset of data that fulfills the condition. So I want to get it. So let's run it, and you can see what is the DF3 looks like now. So DF3 is still a data frame, okay, and I am giving a condition which is only 20. Like you can see 22. That means based on the condition above 20, I get a subset of the data. So this is the way we can also get like an Excel filter, if you think that. So filter is here, okay. So so this is the variable. Look, this is the way we are accessing the data in this case of the column, which is greater than 20, and give me all the data. If you don't give it, then probably will not get only get the portion of the data, not the whole data. Or even it doesn't work because it is a data frame. It requires that operation should be applied across all the rows, okay, and then give me all those rows that fills the condition. That means you have to have this like a comma. So, otherwise you'll get an error like this, okay, undefined column selected. So this is how we can subside, but in the subsequent slide, like the subsequent days, we will use this kind of operation. So you will get to know more about it. But just as a early like introduction, I told you this is the way we can also filter the data, okay? And this is a way we can combine the data, and we can add new rows. You can do just like I explained before. And now for loop. We use the logical operations. So you can see these are the vectors. If you do AND, so this is the AND wise, and this is the there are two kinds of AND. If you run it, you'll get the output in this case, because I have not run it in front of you, but I left it for you to run. So if you say this one, what it does, you can see true. This is doing like a one by one. True and false. What is false? False and false is false. True and true is true. False and true is false. But if you do double AND, you get one single answer from it, because it did compare everything. Like if it is so if anything is false, you get the result. So that is the difference between single AND and double AND. You have an item here, okay? You have an item here. If you do double AND, you get an aggregated answer applying the element-wise application and get a final answer of AND. But if you only get an element-wise AND, this is where only you get single AND. Same like double AND, double vertical or double pipe. This is the difference. So you get a double pipe, you get a single answer by having true or false, but you can say true or false, you get an or, so at least one is true. That's why you get a true answer for the double line, for the double vertical. Okay. And this is the negation of these things. So like means if the vector 2 is false, it becomes all false become true, false become true, true becomes false, true become false. Okay, this is the negation. Conditional operator, I told you this is only if you have a variable. I explained it before, so you can run it, you can give a different value. So if else, the condition is you cannot put else in the next line. It has to be where you finish your second curly brace. Looping, two kind of looping, while looping and for looping. While you set a condition and make sure condition is met or fulfilled so that you can terminate the loop, otherwise it will become infinite. You can use a for loop like this. So for loop requires, oh, I have not explained for loop like that way. So this is actually a list now, okay? And now this is a nested for loop. So you have a for loop starting here. I told you a nested loop. So now look the for loop, what it is doing. So this is a for loop begin, and within a for loop, I have another for loop and also a little bit of condition. So what it is doing, because I have used these things before, but now making more complex when I'm using multiple tools together. What is it is doing? Using a for loop within a for loop with a condition. So in this case, my intention is to read all these things in my fruit basket, okay, get a fruit. If the fruit is banana, then don't do anything, just skip to the next. Otherwise, print the counter. So let's run it and I will explain it. Oh, I have to run this first because these variables are undefined to me now. So if I define, now look, the output is. So first of all, it is printing counter. So first a fruit. So for each item in this list, first get apple. For apple, okay, apple is printed at the end, but before we print apple, we are also counting 1 to max. Max value is 10. So it would print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then apple is printed. Then this loop goes to the second one. Then it gets banana, but if it is banana, then skip it. So doesn't do anything. Then it gets cherry. Then cherry, it gets cherry is not banana, so it goes to this for loop. Then print again 1, 2, 3, 4, 5, 6, 10, and I got cherry as an output. Okay, like this. So we got only banana and apple output in this for loop. I explained function. Function is nothing but a block of code that we can reuse many times. So we use the function, requires a parameter, it can return value, and we can call the functions like this, okay? And it can return value to a caller. In this case, res is the value we are storing the calling of the function, and we can use it later. This is the function. Function could be nested function. It could be, in this case, like this is a function. We can nested function here. In this case, we are calling this function. So let's run it. And then we call this nested function here. You can see it's returning 10 because it is doing 2 and 2 calling first time, then 3 and 3 is called second time, then third time it calls the function with 4 plus 6, then we got 10, and 10 is output here as the output from the function. And this is the function with the outer function, as I showed in the code. This is the definition of the function I have loaded. Now, if you run output, which is actually, and if you say what is output, you can, oh, sorry, what is output variable? It is actually function definition. You can see it is actually waiting for you to invoke again with a value. So which is a value? If we write output of 5, then it takes 5 plus 3, 8, because you have already prepared your function in this case. Now you are really invoking the inner function through another value, but we rarely use this kind of, but that's just for you showing that if you encounter something like inner function, that is also possible, but we don't have very much code like this. Okay, now one thing I didn't explain about the scope of the variable. Okay, so these with this, I think that will be the final concept for tonight. So variable has two scope, local scope and global scope. Okay, so look, I have declared a variable called my text. Fantastic, and I can write the my text within a function called my function, and I can print it. So just simplicity and remove all the variables here so that it doesn't interfere with any other things. And if we print it, you see it's printing. I have not called the function to call the function my function. It can see R is fantastic because R my although I have declared I say my text not here above the outside of the function, it is in a global space. Okay. Now look the same function. Again, my text is here, and I am using the same variable my text here again within the function. Name is same. Okay. So although names are same, but the scope is different. This is a global space scope, and this is a local scope. And if I run it, you can see what is the difference. If I invoke the function, you can see it is printing R is cool. Okay, because this my text is actually cool, and it is using that local reference of the function. Since I didn't have any local variable, it is using the global one as the value. Okay. But how about I want to do really whatever my global variable is, I want to use that in my local reference. I want to create a new instance or new version of my variable. I want to reuse it. So the way, this is the catch. So this is the catch. You have to use the double arrow this to override the value of your global variable to make it override. So it will be clear if I run this code and explain from there. So you have defined your variable my text on a global space with the value called fantastic. I can see fantastic is here. Now I'm defining a function, and in this function, same variable used, but in a global to be overridden. Okay, global should be updated. And nothing has happened yet because I have not called the function. I am now calling the function. The function is defined, it's waiting for me to call. And now I'm calling the function. You can see R is cool. So this is still the same, but let's me print what is the value of my text. And you can see here, my text is already updated to my cool. Okay, and you can print it this. Okay, so but previously, when we have this same variable, the cool was there and the my text was fantastic. Nothing was changed. It didn't change this one. But if we use the double arrow basis, then global, you are like forcefully changing the global to take the local variable content. Okay, that's it. And yeah, and probably string function. I think we'll talk about it will come as handy when we'll be talking some kind of code for the statistics. So basically, you have a string, we can add to a string. Like if you want to add this plus this, we have a common function called paste that will add two strings and print the value of the paste. For example, this is 2, and you want to the concatenated version of the two string, so you can use the paste function. That's it. Okay, and these two packages, I have not mentioned how we can install new libraries and packages in R. And we'll see that very often. If the package is missing, we are not using it, we are not having it in our reference, we use this command called install packages and the name of the package. Okay, so in this case, I would recommend you to install this package called SWIRL, SWIRL, which can help you to as a self-learning tutorial. Okay, just Google about the SWIRL if you want to know more about it, and then you install these few lines and then run the SWIRL, and it will work as a tutor for you to try out teasing out different question, and you can learn R more interactively. Okay, this is like a package that helps you to learn R, it will give you say, hey, how to assign a value. So you have already gone some things, it will ask some quiz and it will ask you to do this way, and that's an interactive way of learning. So that package will help you, and that's an extra resource you can have on your computer. Okay, so with this, I would like to conclude, and I'm sending the session.r as an attachment in this chat, or how should I deliver it so that you can run the code line by line and give it a go. So I can share the file. Is there any way I can share the file? Where is the file share? New share. No. I just stopped sharing now. Then probably I will share the file. Chat. What is the file? I think in the chat, it should be. No, I don't
Sir, I
see
think
any
you can
file
share
share.
with our coordinator, then we have a
Yeah. Okay. So I'm just mailing the R file and the presentation now, and probably you can work the practical sessions on your own. Okay. I'm just emailing now. Okay. To everyone, because I have the email for everyone. I reply all, and I am attaching the resources. Desktop. Session 1. Okay. I just email everyone the PowerPoint, the PDF file of the presentation, and the session on R file, which is the source code I just showed you. Okay, so it's now your time to just run and review the recording and self-explain yourself once again. Okay. So I think I can finish my session here today, and I leave up to you to do those practical works, and probably from the organizer, they will maybe here they can help you if you have any difficulties to run those script. And we'll be seeing tomorrow. I think tomorrow we'll be starting earlier because it is getting too late for me. It is already 11 o'clock, 11:30, nearly 11:30 at night at me. And Ramadan will be starting. So our Ramadan schedule wise, we'll be starting early so that I can finish at my 4 or 5 o'clock based on the time. So probably your coordinator will tell you the revised timing.
So it will be from tomorrow?
Yeah, it's from tomorrow. So from tomorrow, the class, you'll start your is it like a 10 o'clock? Your 10 o'clock in the morning. Yeah, which is my 9 o'clock. Oh yeah, your 9 o'clock. Then my 1 p.m. Mustafiz, are you there?
ভাই আমি আছি এখানে।
Oh, yeah. অনেক tomorrow ক্লাস কখন হবে? এটা কি অ্যানাউন্স করে দিয়েছো?
আমরা গত সপ্তাহে জানিয়েছি। আমি একটু ভাইয়ের সাথে কথা বলে আজকে আমরা জানিয়ে দিচ্ছি। তবে খুব সম্ভবত কালকে সকাল 10টা থেকে।
10টা থেকে, আমারও সেরকম। হ্যাঁ, 10টা মানে আমার 3টা থেকে।
জি।
আমার 3 to 5।
আজকে যখন আগামীকালের লিংক জেনারেট করছি, আমরা সাথে সাথে জানিয়ে দিচ্ছি।
ওকে। সো সো আমার মনে হয় আমি আজকে এখানে শেষ করতে চাচ্ছি। সো সবাইকে অসংখ্য ধন্যবাদ এবং পেশেন্ট হিয়ারিং এর জন্য। আর obviously you guys did awesome job because it was so intense a content, but if you can have it and if you can digest it, you are there. Okay, and I have full confidence on you that you will be able to like knock it out. সো আমি মনে করি যে আরেকটু এক্সট্রা এফোর্ট আরো কিছুক্ষণ, যেহেতু আমার অনেক রাত হয়ে গেছে, আই হ্যাভ টু সাইন আউট, বাট আই লিভ আপনাদের এটা রেখে দিচ্ছি। আপনারা এই রেকর্ডিংটা শুনেন এবং আবার এই এক্সারসাইজ গুলো করেন, দেন ইউ উইল বি আপ টু দ্য স্পিড। ওকে অনিক, আই এম সাইনিং অফ নাও।
জি, আমরা সেশনটা এখানে শেষ করছি। আর আজকে আমরা আপনাদেরকে ইমেল করছি যে আগামীকাল সকালে আমরা কখন শুরু করব। তো এই পর্যন্ত রেখে আজকে মাগরিবের আজান দিচ্ছি, আমরা বিদায় নিচ্ছি। আপনারা ভালো থাকবেন, দেখা হবে। আসসালামু আলাইকুম।
স্যার হ্যালো।
জি
স্যার, এটা তো স্যার মানে আজকে রেকর্ডটা পাওয়া যাবে স্যার, যেটা হলো আর কি। স্যার ক্লাসের রেকর্ড তো আজকেই পাওয়া যাবে নাকি স্যার?
আজকে পাওয়া যাবে, গুগল ড্রাইভে আমি আপলোড করে দিব।
আচ্ছা ঠিক আছে, ওকে।
জি।